In this video we're going to look at how to complete the square. So we're going to look here at 4 examples. We're going to deal with 3 of them in one form, and then I'm going to show you a different method we could use as well. So this first example, we want to complete the square for x squared plus 6x. Now we can only use the method for completing the square if the coefficient of x squared is 1. And in this case it is. And what I'm going to do is I'm going to open up a pair of brackets, and I'm going to say that brackets are squared, and I'm going to put in x at the beginning of the bracket. And this is how we're always going to start. And then what I'm going to do is I'm going to look at the term with the x in it. So here I've got 6x. And I'm going to half that, and I'm going to write that inside the bracket. And then I'm going to subtract that squared. And now I have completed the square. I'm just going to tidy it up a bit, so I can rewrite this as x plus 3 squared subtract 9. And I could expand this bracket and show that it is indeed the same as the bit at the top. Now the reason that this works is because basically if we just expanded x plus 3 squared, we'd get x squared plus 6x plus 9. We don't want the plus 9, so we just subtract it. So the second example, again the coefficient of x squared is 1, so I can set up my initial bracket with the squared and put an x at the beginning. I will then consider the x term, which is negative 4, so I will half that, which will give me negative 2, so I subtract that squared. Then I have the number term, and I'm just going to put that on the end as well. And now I'm going to simplify again, so x minus 2 squared subtract 4 plus 6, which is then x subtract 2 squared plus 2. Now in this third example, I do not have a coefficient of x squared of 1, it's 2. So I'm going to first of all just factor 2 out, and now the term inside the bracket here I can complete the square for. I'm just going to keep everything in square brackets for now, just so they can keep out of the way and they don't get confused with these curved brackets inside. So here I've got a coefficient of x of 3, so I'm going to half that, and I'm going to write it as an improper fraction, 3 over 2. Subtract 3 over 2 squared, and then plus 2 on the end. And now I'm going to simplify those. So still keeping the 2 outside for now. X plus 3 over 2 squared, subtract 9 over 4 plus 2. And at this point I'm going to do 2 steps at the same time. I'm going to do minus 9 over 4 plus 2, and I'm going to multiply it by 2. So that will give me 2 lots of x plus 3 over 2 squared. Now negative 9 over 4 plus 2 is negative 1 over 4, so when I times that by 2 I get negative 1 over 2. Now this final example I'm going to do by recognising that I'm going to end up with something in this form, where a and b are numbers that I can find out. So what I'm going to do is I'm going to expand this bracket, so I'm going to get x squared plus 2ax plus a squared plus the b that was on the end. And now I'm going to do what's known as compare coefficients. So I can compare the 2x terms, and these two must be equal. So therefore I know that 2a is equal to 3, and therefore a is equal to 3 over 2. And and now I'm going to compare the number terms, so negative 2 and a squared plus b, because that's the terms with no x's in. So I know a squared plus b equals negative 2, so 9 over 4 plus b equals negative 2, so b equals negative 2 subtract 9 over 4, which is going to be negative 17 over 4. And so I can now write this in the form I had before, so x plus a, where a was 3 over 2, and b is negative 17 over 4, so subtract 17 over 4.